All right, thank you. So I got the green light to start this conference. So I'm Frank Hovorka, I'm the president of Building Smart France, and I'm very happy to welcome you for this conference in Lyon and also virtually on streaming. And it's my pleasure to give the floor to Mr. Pierre Rampart, who is the representative of the organization, and to give the introduction speech. So, Pierre, please, the floor is yours.
Ladies and gentlemen, good morning. I'm head of the construction company Rampart for 30 years. Our activities are the construction of water and energy infrastructure, real estate, and the prefabrication of concrete elements. The group employs 600 people with a turnover of 130 million euros. Very much involved with professional action in the civil engineering industry, I participated in the creation of AMPERE here in Lyon, an innovation cluster that brings together 130 members, including universities, companies, laboratories, and contracting authorities in the Auvergne-Rhône-Alpes region. For the last 2 years, I have also been president of the Innov Infra Hub. What is it? The Innov Infra Hub is a national grouping of innovation clusters in the civil engineering sector. I would like to welcome. The 4 clusters are ECORS in Dijon, Bourgogne, NovaBuild in Nantes, ODIS in Bordeaux, and Endura here in Lyon, whose president is Paul Gallonnier. They are all dedicated to accelerating innovation in construction and the development of projects involving the following traditions: technological, energy, environmental, and digital. The digital transition is the focus of about 1/3 of the projects that we support. All construction companies are impressed by the technological advances based on increasingly robust numerical modeling. Already in 1980, simulation made possible the construction of the Grand Arch at La Défense in Paris. Today, they are the heart of the design of the experimental reactor ITER. And as a very local example, I can point out the Museum of the Confluence in Lyon that I invite you to visit. With the increase of computing power, we are also seeing the emergence of artificial intelligence applications. These applications are clearly based on access to data that must be created at reasonable cost through reliable sensors. Digital technology really and truly fuels an active project development. As an entrepreneur, I can say that these technological advancements are gradually having an impact on my business. At the start of the BIM concept, I felt it was really geared towards consulting engineers. And yet, at the same time, our teams gradually integrated information management and communication concepts. Without necessarily knowing, they began the company's BIM transition. My participation in the previous edition of InfraBIM Open in Finland confirmed my feeling that BIM is now everybody's business. We, the company, have a role to play in this digital adventure. Its use will certainly help us to improve productivity, but will also allow to take other dimensions into account. Sharing information between all the trades, making joint progress on projects, the carbon impact of our construction proposals, the improvement of our technical dialogue with the project owners. It is for all these reasons, both structural and professional, that when the Innov Infra Hub was asked to participate in the organization of the InfraBIM Open conference in France, We said yes, of course. So, ladies and gentlemen, I sincerely hope that you will make the most of this Congress. Thank you for my English.
Merci beaucoup, Pierre. Thank you very much, Pierre, for your words, introduction words, and thank you again for the great organization of this conference today. The second speaker is Tammo Servoljuanen from Finland, Tervetuloa, or something like that. It means welcome. I try to say welcome in Finnish. I learned some words, but I can use only in the evening during the dinner. So, please go ahead.
Thank you, Frank. Your Finnish is improving all the time. Thank you. Can I have the slides? Slide? Is it here? Okay. Here, okay. Yeah. Bonjour, Madame and Messieurs. Hyvää huomenta, naiset ja herrat. Good morning, ladies and gentlemen. My name is Tarmo Savolainen, Chairman of Building Smart Finland, and on behalf of Building Smart Finland, I want to welcome you all to the fourth InfraBIM Open here in Lyon. InfraBIM Open, the big festival of open infrastructure BIM. 3 years ago, when we started to discuss about InfraBIM Open here in Lyon, we didn't know how the world will be. There came COVID-19, COVID-20, COVID-21, COVID whatever it will be. But here we are, and I'm extremely happy for that on the bottom of my heart. This is already a great success story. I really hope that this is the beginning of a good story. I really hope to see you all here in Lyon again in future, 2024. Let the big festival of open infrastructure BIM to beginning. Today, it is time to hear interesting presentations from all over the world and contact with people here and virtually. I want to thank you all participants here in Lyon and virtually. Without participants, these events wouldn't be anything. I want to thank you also all the sponsors. With your support, this event is possible. I want to make a special thank you for great French organizations, Building Smart France, Hub Innov Infra with Indura, and Mint with IREX. Thank you, merci. The last but not the least, I want to thank you, the organization committee, everybody working for this event. You have made enormous amount of work. And for me, it has been a pleasure to work with you, everybody. Thank you. I still want to remind you for next year. Next year, InfraBIM Open will be held in Tampere, Finland. Put the dates to your calendar already. On behalf of Building Smart Finland, I cannot promise you as good food and wine as we have here in Lyon. But I can promise you much more colder weather and great presentations like we have here today and tomorrow. With these words, on behalf of Building Smart Finland, I want to welcome you all to Lyon and to this event. Let the festival beginning. Bienvenue, tervetuloa, welcome.
Thank you very much, Tarmo. Merci beaucoup, Tarmo, pour ces mots d'introduction. Je vais donc maintenant passer la parole à Monsieur Pierre Benning, qui représente Mind et qui va nous donner quelques informations et quelques mots de bienvenue également. Pierre.
Bonjour à toutes et à tous. My name is Pierre Benning. I'm a co-director of the French national project MIND. I speak today on behalf of Bernard Scher, the president of the MIND project, who was unable to join us today. I'm really pleased to be here with you in this splendid building. Really pleased to be with you, and I thank you for coming to this event dedicated to the infrastructure. MIND is very, very proud. It's an honor to have been associated to this event, which is taking place for the first time in France, in Lyon. It's not only an honor, but it's also with a great interest for that the members of the different MIND working groups will attend. First, it's an opportunity for them to present some of their works in progress. And secondly, they will attend very diverse lectures that will enrich our own work. The program is dense. The subjects are varied: data management, data creation, open bin applications, and also IFC development. In short, there is something for all of you, and the presence of the European political bodies proves that they are sensitive to the topics we are exploring today for the well-being of the citizens, but also for the well-being of our planet, which is very sick. So I wish you a good open beam infra. I hope that you will find here what you came for: ideas, answers to your questions, information on standardization, networking, and the pleasure of being gathered between infrastructure professionals. And I congratulate the different teams of the organizations in this event. It's a very special sanitary context, and I'm very pleased to be here with you. So have a good open infra session. Thank you.
Merci beaucoup, Pierre. Thank you very much for this very warm introduction speeches from the beginning. So I'll be very short in order to not make you waiting for the next keynote speakers and also for the discussions we will have. So I'm Frank Hovorka, as I said. I'm the incoming Building Smart France president since this last year in June. And I'm very pleased as Building Smart France president to welcome you too here in Lyon and for this InfraBeam event, because as you understood, we are at a point where we could think about cross-fertilization between infrastructures and real estate, between what we do in infrastructures, data development, and construction and real estate. Clearly, also, we have a tipping point where the data management, thinking about how we can have a value about data transmission, data evaluation, and how we can think about how to integrate the work we have done in data access for the climate change, for greenhouse gas emission, for life cycle analysis, which will be one of a big topic in France for the coming years because of a new regulation of life cycle assessment. We also have to think in product life cycle management. So it's clear that it's at this moment where we need to think about not only the data about a component or a building or infrastructures, but also the metadata which are linked to the information you give to a certain component in the building or in the infrastructure. Calculate a greenhouse gas emission linked to life cycle assessment. So all this topic will be covered in the coming 2 days. And I do hope that we will find together this cross-fertilization that is needed to access data evaluation that we need. But first of all, I will give the floor to Mr. Petrie and Simmons, who Richard Petrie is the president of Building Smart International. Are they online? Richard, are you online?
I'm here. Can you hear me?
Yes, we hear you very well. We'll try to switch you on the screen.
And will my slides be there as well?
Yes, I think we will try to do that.
Excellent.
Just a minute. Yes, yes. So now you are on the screen, Richard. Good morning. Nice so you can speak. And in a couple of seconds, we will also put the slides. Here you are. It's done. So you can start. Thank you, Richard.
Perfect, Frank. Well, first of all, I want to really say a very big congratulations to the French chapter and the Finnish chapter for managing to get this event together. I know it's really very difficult and a great deal of hard work to manage these types of events with the level of uncertainty that we have had recently. And so really congratulations. And I suppose, want to talk today about, why this is so important, why it's important that we are working together with other standards, open standards bodies such as OGC, and that your work in our community collectively, everybody here involved, is so vital to sort of progress with the digital transformation. Now, very good. So I'm just really, as a quick reminder that, about the mission of Building Smart to fully enable the benefits of digital ways of working for the built asset industry. And again, this implies for me open standards, and it implies the client as part of the industry. I think most people have heard this before, but I'm really reminding you, you're all by joining in at this event and thanking you for your collective contributions. We work on an open, neutral, not-for-profit international basis and are always looking to, let's say, expand our reach, both in terms of the domains we cover and the geographies. I wanted to perhaps have a recap of some of the things that we did last year. There was, notwithstanding COVID, we were very proud to host 2 virtual summits. We've done a lot of work on the sort of publicity and communication side, and I'll talk more about that later on. We have also relaunched the BSDD in a new technical format. A great deal of work has been done on IFC5, and I'll come to that later. I was also very pleased to welcome Schneider Electric to the Building Smart community, and I think this will be a major new strategic initiative for Building Smart, entering, we are going to be creating a new sustainable energy management room, which Schneider will help us launch. And Trimble have also joined our Strategic Advisory Council, and that brings a very strong complement of the senior, let's say, larger vendors supporting the work we've done. So I'll come on to some of that later, but please do look at the white papers. And in terms of ambitions for this year, which I think is perhaps appropriate, we have a lot of things underway in terms of the technical work we're doing in the standards program. And it's very important that the momentum behind those projects continues. It's very important that the support services in terms of the BSDD and our use case management service are enabled so that the product of the work that we are all doing is easily available to clients and end users. As I've said, I want to have ambitions to increase the reach. I'm very pleased with the growing relationships we have in Latin America, and I'd like to see us reach into some new territories, also to expand into some new domains, particularly thinking of the electrical domain at the moment. Quality assurance, which is always vital, now comes to the fore, to the stage where our standards are making progress. So we are looking to expand the push behind the professional certification and the software certification as a priority this year. A reminder of the breadth of our chapter community now, and this is always growing with new expressions of interest. There are, expressions of interest at the moment from Morocco and from, let's say, we have these ongoing links with Latin America as well. A quick reminder of where there are IFC mandates around the world, growing worldwide adoption. And given that this is really started from the platform that was largely focused on buildings, I'm very pleased about that. Of course, we are doing a lot of work in infrastructure now. Key drivers for this are the requirements for data flexibility. I think that is going to be a modern, forward-looking requirement. Productivity. Really, I'm talking there about the World Economic Forum challenge the construction sector to be more productive and efficient, and sustainability. And I think all of these major worldwide drivers require and demand open standards across and interoperability to be fully effective. So just to quickly talk about data flexibility, it's very clear that in the modern digital world, data rights will determine wealth and power. Data rights aren't things that just naturally pop out. Actually, you as clients and users have to figure out and defend your own rights and lobby the people who will set the rules and regulations in your environment. In order to have data flexibility, the key foundations are open neutral data standards and what I call critical enabling web services, and that's where we in Building Smart are focused. I want to talk about productivity because it's very clear to me that there are, depending on who you are and where you sit in the value chain, productivity means different things to different people in the value chain, but it always comes down to these access and opportunity, financial opportunity. I want to talk about sustainability because it's very clear to me that when we talk about sustainability, we are really trying to measure, let's say, data and information that is currently held in many different silos. We're looking either at a whole value chains of product or material that perhaps is not even at the moment seen in the same value chain or understood, and to manage then this data across these different silos as they exist today requires the application and use of open data standards. And I believe that the work we're doing certainly in Building Smart can contribute to the goals of from 6 through to 13. I want to talk then really about the importance of you joining in this community and having control of your digital destiny. And that's really one of the key things, the values that you will get from working with open standards, learning how to use them and helping us expand both their coverage and improve their application and usability through better web services and guides and help. I want to talk now particularly about some of the work that is a very significant milestone for the world at large, and it's the reason that for this conference is so important. This year we will take to ISO the expanded IFC schema, which covers major infrastructure domains, as we're showing here on this chart. This is a step change in the domain coverage, and it should not be underestimated the importance of this in terms of advancing the use and availability of open data standards. It is going to go in terms of we're initiating the ISO process this year, and that will probably take 18 months to 2 years to progress. But we do anticipate that by the middle of this year, we will have enough feedback to really be clear and absolute that we have reached the sort of final standard status for this work. I also want to say that the ecosystem on which supports these schema is improving as well, and that's very important. We are now able to publish this in modern languages, and we are improving the availability of the management tools that support it and the openness of these support tools. So the environment in which we develop and publish these standards is very much improved. The format in which they are published will be much more flexible, and we're supporting these services. Feedback. Somebody do that. We are expanding now. We're trying to reach I don't know what to do about that. Can somebody mute the return to me? Thank you. The global reach is obviously a very important aspect, and my point of this slide is really to emphasize our focus is not on publishing standards for the sake of it. We are really trying to make sure we take this all the way through to making them usable and available in vendor package software first of all, but also then later on usable for end users and clients. And I think that's absolutely crucial, and that we're committed to doing this worldwide. I think collectively, all those things really represent a very significant step change in the availability of, let's say, Open BIM as a meaningful working tool. And I hope that this will also enable us to really build this critical mass that I think is needed to help with the extending the use case applications and dealing with some of the real detail elements that actual end users will want to make it specific. And I think we're getting a lot closer to that full tool set that people need. I was just really picking out here an endorsement from Jack Dangerman. We got some very senior and very good endorsements through our podcast series, but clearly it's also nice to have this one from, say, Esri, who is supporting very much the OpenGIS community as well. Working with OGC, I mean, I wanted to make the point, first of all, that you know, OGC and Building Smart have been working together for a very long time, and certainly it predates, you know, my own establishment here. You know, the demand for BIM and GIS interoperability has been foreseen a long time ago, and there was early work done to ensure, let's say, conceptual alignment between the schemas. Now we are focused on this sort of, probably, I picked out 4 areas of common interest: semantics, placement, geometry, and interfaces. And we have joint initiatives at the moment in terms of an IDB pilot project and a white paper that's in draft. So it's a pleasure to be sharing this platform with Scott, and you know, lovely to be working again together. Just quickly now, I'll run through want to really bring to your attention some of the work that we've been doing. And it's important here because I think people need to know that this isn't a sort of academic activity, that we really are some demonstrable examples of the work that's being done. These examples can be very useful for people who don't know how to use Open BIM standards. So please take a look at this yearbook. It's a very valuable collection of our, the winners from our awards this year. There are detailed domains, covers a range of domains, examples from across all the different fields that we cover. There are, as well as the yearbook, there are some full case studies that have been written up and developed. This material is aimed at expanding our reach, making sure that we can communicate with people who are perhaps not inside the detailed technical circle that have done the important development work. So please pass on the availability of these and publish those. And of course, we have also had an awards program this year. We're in the process of capturing all that information, but we're delighted really that there's a lot of engagement both from the community in supporting and making that a truly sort of open process, the judging, and also the engagement from people who submit projects. And I'd be very excited to receive projects from any of the companies in the conference in the next 2 days. And the 2 white papers, one is a joint paper, a paper with, let's say, on the facilities management, and first of a series of 3 aimed at explaining why operations management and facilities management are such important topics, and the contribution that Open BIM has to offer there. And the other with GS1, which is about working on specific workflows for product. And a lot of those deal with things like material passports and the sustainability agenda. Some very important and valuable themes picked up in that white paper as well. So with that, thank you, a collection of links that I hope people might find interesting and useful. And with Scott, I'll be happy to hand over to you there. Thank you very much, everybody.
Thank you very much, Richard, for this introduction. And you mentioned the building passport, and for your information, for the first time, the building passport that digitization is clearly written in the new draft of Energy Performance Directive from the European Commission. So it's quite interesting to have that in mind, that what we are doing in terms of standardization is already written in the new directive that could come in force in the next year. So the European Commission works are things that we have to look at and to maintain. Now I will give the word to Scott Simmons. Scott, are you online?
I am, and hopefully everyone can
Yeah,
hear
great.
me, see me, and maybe see my slides.
Just a couple of seconds as we switch the screens in order to put you online. Yes, you are on the screen, Scott.
Great, thank you very much. And I don't see my own slides, but I have my. If everyone sees why OpenGIS, we're in great shape. Bonjour, mes amis. Hello, my friends. It's a real pleasure to be here with you today, and a great pleasure to follow Richard because he really set the scene nicely on the Open BIM side. I'm sorry I can't be with you today live in person, but we all know how these things have been going lately, unfortunately. And so today what I want to talk to you about is why OpenGIS. If you think about the way we exist in our world today, we live in a continuous world, but we model in a discrete world. And so what we see, what we exist in our world may be very continuous. So we walk inside and outside of buildings and we travel between them, but we don't always model as such. And so I want to tell you a brief story to illustrate this point. So were I to be with you today, a few days ago, my alarm would have gone off at 5:45 in the morning. I would have walked downstairs, made myself a pot of coffee, taken a look at the temperature outside, made sure that the heating was on when I left my house, take a quick shower so that I'm clean, plan my route to the airport, hop in the car, drive down to the Denver International Airport, face the snowy route that I would have this week, but arrive at the beautiful airport, find myself an airplane, land somewhere in Europe. I don't believe that landing is actually in Europe, sorry for that, and make my way to see you in Lyon. But the story is a bit more complicated than that, and it only occurs because of a whole lot of work that we do in this community collectively in modeling our world. And so I'll tell this story again, but a little bit from a perspective of the carbon footprint I'm putting upon the world now when I do a trip like this, and perhaps how we can mitigate some of that. So again, I woke up early in the morning, got myself some coffee, but in order to do this, I had to generate or use some electricity that's generated for me. Normally, the rooftop of my house in the morning would be giving me almost all the power I need for this. But it's 2:10 in the morning here right now, and I'm not really getting any electricity from the solar panels on my roof, but instead I'm fortunate enough to live in a community that gets 60% of its power from wind energy. How do we get that wind energy to us? How do we consume that energy? It's really a twofold problem. Partly, we have to model the ideal placement of the infrastructure to generate the electricity. In order to do this, we have to understand things such as the terrain of the land, the predominant wind patterns, the placement of cities, ranches, open space, et cetera, where we might build the infrastructure. All of those layers of information, in order to just calculate where the ideal spot to set wind power is, requires open exchange of information and consistent, standardized formats so that all these formats are interoperable and so these calculations can be made. And again, this wind power plant, which is very near my house, you see a picture of the mountain behind my home in this photograph, and I'm at the very, very top of the little map on the left side there where the little diamond is, north of Fort Collins. But someone also has to do the engineering to place these turbines. someone has to do all of the actual open BIM work to ensure that these turbines are described appropriately and maintained for their long haul. My weather is important in what I'm going to do with my electricity over the course of my trip. If I'm leaving the house alone and no one's here, I have, fortunately, an Internet of Things connected thermostat to control my power. Yes, sorry, my temperatures are in Fahrenheit. My weather information is coming to this IoT device geolocated based on where this device sits in my house. And so I have the weather forecast for the day on January 7th, and I'm able to make this adaptation myself. As you'll note in the lower right of the screen here, I'm heating it with gas, a little bit maybe of a heavier carbon footprint. Someone has to pull this gas out of the ground. I know some people in the audience there are geologists like myself. A geologist has to go out and find that gas. There's a huge amount of geospatial and geologic data that must be integrated into a common OpenGIS platform in order to even discover the gas, then to prepare to drill a well, then hand over the work to the engineers to build the infrastructure such that we just get the gas out of the ground. Then we have to transmit that gas from the well site to my house. And again, this entirety of this gas and oil transmission system across the United States to bring us our gas for our own home heating is quite complicated, and again, utterly dependent on interoperable geospatial information. We have to know, again, the characteristics of the land, where the pipelines are located, how they're connected, how they tie into the infrastructure, all the way down to the smallest level, as in my house where it enters. I'm pointing at that side of my room where the gas enters my house. And speaking of networks, I also chose to drive to the airport myself. Could have taken a bus, but it takes too long, and during COVID, they're not particularly safe. So in order to make this route planning to get from my house to the airport, ideally, I'm going to choose the carbon lightest path possible, which I've highlighted in blue. So I now have the ability through my mapping system to not just look at the traffic, but also to look at the carbon footprint of my drive. But I have to get that road network to begin with. So somebody actually has to go out, collect overhead imagery of the area, in this case, say aerial photographs. A technician has to digitize the road. That road has to be aligned to the photograph, and that road has to be part of a network so it can all be connected up for these calculations. At the same time, in order to best leverage this road network, I need to integrate real-time traffic sensors so that I can pick, again, the ideal traffic routing, reducing my footprint, trying to make my drive as safe as possible and as carbon neutral as possible, or carbon neutral or carbon light as possible, based on all this real-time information. Again, it must all be geolocated, it must be consistent. And many of those traffic sensors and other sensors that we're using are also perhaps supporting information about the buildings in which they're located. I could have chosen to drive my old beat up truck to the airport, but it was covered in snow, so I chose not to. In order to pick, again, my vehicle, I need to get the oil to my truck. Similar to the story of the gas, someone has to go find it, someone has to bring it out of the ground, someone has to pump it from the oil field to the refinery and ultimately get it to my car. Every step of that process requires open integration of the data necessary to understand where I'm finding my resource, how I'm transporting my resource, and how I'm delivering my resource. And as you're thinking through this and looking at even the pictures, you're understanding that this is not a simple spatial problem of those pieces of infrastructure to hold that pipeline above ground and keep it from freezing. Our engineering data and are built at a civil or even a BIM scale. Finally, I am going to drive myself down to the airport. I heard it's a windy day. I need to look at what are the road conditions. Will it be too windy to drive? Will they close the highways? Fortunately, through detailed modeling, someone's able to pick all the information about the wind conditions and predict where they might be and integrate that data, again, to an interface that can be delivered directly to my vehicle to tell me about wind conditions. And in fact, on a very windy day recently, a number of vehicles were blown off the road. This just happened about a week ago. And thanks to these Internet of Things connected weather stations along our way, rerouting was possible based on wind conditions and traffic and damage. Finally, I arrived at the airport. This airport is under construction. If any of you have flown into Denver lately, you'll see lots and lots of construction and clever pictures of aliens and cats. That's another story for another day. The entire remodeling of the airport, again, it's a problem of spatial aspects, but also of infrastructure and open BIM to ensure that this construction is addressing the needs of the airport and not inconveniencing me too much for my flight. This airport happens to leverage a lot of solar power to operate the airport. The only way you can place solar panels is to understand where you have solar energy. And so again, someone has to do detailed modeling of the solar potential over the continent of North America, in the United States, and ultimately in Colorado, where I live, and place that infrastructure at the airport and ensure again that the optimal balance of power at the airport versus where we are existing is ideal. And finally, I get in my plane to fly to someplace in Europe for my gateway to Lyon. The entirety of that flight is through a huge interoperable collection of standards administered by the Federal Aviation Administration of the United States and Eurocontrol in Europe. And these all interoperate to ensure that the weather information, the flight information, the aerospace closures and openings are all integrated as the entire flight moves from North America across the Atlantic Ocean and over Europe. And all this information must be exchanged real time as well as predictive, and it all must be exchanged in a standardized format. Every aircraft in the world must exchange this same information via the same original sources and use that for the planning. It's not a simple problem. As you can see, the architecture based largely on standards from OGC and the World Meteorological Organization and these aviation authorities must fully integrate to ensure that we travel seamlessly. And finally, I land at an airport, ideally to find my way out of the terminal using an indoor mapping standard to help me navigate the space, perhaps with a little bit of augmented reality. And there was my trip. So how do we enable that in OGC? Well, really, our process in OGC is one of developing standards and thought leadership for all things location. Our focus is on findable, accessible, interoperable, and reusable spatial content, fair access to data. And we do that not only through building standards, but through partnering with people such as Building Smart and others of you in the community to ensure that those standards we write and those standards that we help develop are interoperable and sufficiently integrated with other domains of practice so that we have this continuous world in which we live and not the discrete world in which we model. We bring members together from the commercial space, government, and research and academia to ensure that these standards are developed to not only satisfy the needs of the end users, but also to be market relevant and sustainable from an economic standpoint. We have millions of data sets on over 350,000 data servers out there right now describing the same information. And you see a lot of these examples down at the bottom, aviation flight safety, et cetera, geologic data, et cetera. All of these standards exercised through innovation. And specifically, with Building Smart International, we've been working towards what we refer to as the integrated digital built environment assessment of where we are in this world and how we model this world and the continuum between traditional geospatial modeling, where I come from, and building information modeling, and ensuring that information provides a round trip. Information built in one set of domains moves to the other, is useful, and can be brought back in a continuous cycle. And we do this through really tight partnerships. In this diagram I love just because it's so complicated. Look at all these interrelationships with a number of the organizations you've worked with, or many of you may now work with, to ensure that all communication amongst us and our standards is as transparent as possible and that we interoperate as much as possible. And so for the remainder of this week, when I am with you, I'd like to help us understand how the spatial aspects, the big picture, is just part of tying together lots and lots and lots of more discrete pictures. It would be wonderful if at some point we are not modeling this world completely on a discrete basis. At the moment, our expertise makes that something of a reality, but with time we will live in this continuous world that we model. And with that, I'd like to thank you very much for your attention today. I look forward to speaking with you virtually this week, but we'll certainly see each other in person before too long, I'm sure. With that, thank you so much.
Hi, Scott. Christophe speaking. Thank you very much for your presentation. And just I want to underline, before to introduce the other topic, that it was mentioned by Scott and by Richard, the white paper about the geotechnical issue, and you will have a very detailed presentation of this technical issue on tomorrow morning with Michael Bofis, because it's something coming from mine project about the federation of model between BIM and GIS regarding the question of geotechnical issues. And it's a very, very new approach, and it's already funded by mine in France, and we are going to have a call for participation in OGC in order to implement this initiative, both in BIM software and GIS software, in order to have a representation of the underground everywhere at any scale of the territory. So thank you very much, Scott, for your presentation. Thank you, Richard, for that. It's a very great introduction for the new topics arriving for this morning on the question of low carbon strategy. But before to move on the next step, I received this morning a present from the Finnish chapter for this because we are speaking about this conference since 2 years or 3 years, something like that. So I'm going to open that, and so that is the chocolate. Thank you very much. But much more important is for to translate French to Finnish. So thank you very much. So I'm very proud for that. So thank you so much, because it was really an effort we have done since 2 years to co-organize this conference here with the Finnish chapter, and we have to say that we succeed to do that today because we have a full support of the Finnish during this very hard period of COVID, and they are really supporting to maintain this conference in life. So thank you so much, and we are very proud because the result is already there. So the next step is the following one. We have 2 keynote speakers arriving. Adelaide Ferrai, who is the expert from ENPC, receiving an award from IEPCR about the question of PLM. It's difficult to translate SCV in French, SCV to PLM, because it's not at the same level between French and English, about the question of materials in infrastructure. So Adelaide will be introduced as a keynote speaker, and then she's in line. And then we will have Arvea coming from as consultant and expert from the European Commission about the low carbon strategy in Europe and over the world. So it's something new for the BIM area to introduce the low carbon strategy, and that it was really the willing we have commonly with the Finnish chapter to have something very new on this conference. So thank you for that. So we want to have Adelaide online. Hi, Adelaide.
Yes. Can you hear me?
Yes, we hear you. You are on the screen, and
okay,
and then you can start your presentation. Thank you very much, Adelaide.
Thank you for inviting me, and so for the.
So if you can speak higher, it could be great.
Okay, so just the prize was a prize for the work of Anne de Bortoli, which is in the room. So it's not mine. Just we share it, and that's the work of her thesis. So I'm going to speak of life cycle assessment. So as said Christophe, I am Adelaide Ferrai, working in Navier Laboratory, a laboratory of École des Ponts Paris-Tech, and I'm working on the question of life cycle assessment and their adaptation to the construction sector. So I will present you what is this methodology and how it can be used. So first of all, I just wanted to begin by trying to give you elements that permit to understand why it's important to consider environment while we talk of construction materials and structures. So this graph presents the mondial emissions of carbon dioxide since 1990. And these data have been measured by the International Energy Agency. What you can see is that emission increase. And, oh, sorry, I go too fast. I have just added on this graph different climate conferences, and despite these conferences, carbon dioxide increase.
We are still on your first slide, Adelaide.
Ah, okay, that's strange. So it doesn't, I am on the third one, so it doesn't work. I try to share it again. You see it?
No.
And here?
Not, no.
What is the problem?
On n'a pas le retour?
To share all my screen, I don't know if it's going to.
Est-ce qu'on passe à la présentation?
You see something or nothing?
No, nothing happened. So you are on the screen, but Adelaide, what I suggest, Adelaide, is so you sent to me this morning your presentation.
Yes.
Okay,
exactly.
so I'm going to load that, and during this time, ouais, okay. Tu l'as déjà? Okay, we are going to use your presentation from here, and you have just to drive me.
When you have to, okay.
Do you hear me, Adelaide?
Yes.
Yes.
So I will just say you when you have to change.
Non,
Sorry,
pas celle-ci,
I
non.
don't understand why it doesn't.
Non, tu l'as
work.
pas. Okay, so what you are going to do, you stop your presentation. I'm going to load it right now, and we are going to ask to Arvia, she's here. Yes, and you are going to restart your presentation after the Arvia presentation.
Okay.
You stay in line.
Okay.
Okay, we are going to proceed this way. Arvia, you have the floor. So Arvia, just to say that something, she's coming from Cologne, Arvia, and she used a train to come for low carbon approach. You have to 7 hours of train for that.
No, that is actually something that we are.
You have to use the
yeah. Good morning. Thank you very much to the organizers. Thank you very much to all of you for being here. I was very pleased to be invited to talk today to your companies and to you as individuals, because your sector, the construction and infrastructure sector, is one of the highest consuming sectors and industries in the world, both in terms of GHGs, greenhouse gas emissions, and resources. And 40% approximately, according to the UNEP, of total global emissions depend on the complete supply chain of construction and infrastructure. And 70% of the buildings and infrastructures that we do need to build for the next decades and for the next generations are not yet being built in so many countries. And what is going to happen? We are at the verge of a real transformation in which and of which you will be part. You are at the same time an element of positive development and a threat. Why? Because the increasing digitalization that you represent, and that is going to allow us to do things that have never been done before, in terms of the granular understanding of the reality, the flows of materials, the flows of energy, and the granular understanding of how we live, because energy is the fundamental of the matrix of our societies. Well, this knowledge is permitted, is allowed, is recovered through this incredible amount of sensors and the data transmission that is becoming a tsunami, as we all know, and that is going to increase the quantity of energy and electricity consumption globally to a level that is going to be an additional threat if we do not manage and design in the right way the industry's development. And this is not only the responsibility of the companies, but especially of the regulators. And once again, we need to get out of the silos mentality in which every single industry is thinking about their own specific approach, market, business models to maximize a very tiny section of a profit, but to start thinking collaborative, in a collaborative way. And this is where you are important, because this collaboration is embedded in your mentality, in your thinking system. And this is what we need to transfer to other sectors on a very daily basis. And
second one, because
Yes.
I began just before. So I was saying that, but a lot of things have been said just before, so I think that some you are going to hear things twice this morning.
Yeah.
So I was saying you that emissions of carbon dioxide increases, and if you go to the next one, you can see that even on this graph I put some conferences like as you see, Rio de Janeiro, Kyoto, things like that, and we can see that whatever the conference is considered as a success or a failure, carbon dioxide emissions continue to increase. The only thing that induces a decrease is an economic crisis, like in 2008, or the COVID, for example. So it's important, as you've said just before, as has been said just before, to act. And if we focus on the contribution of the building sector, which represents in France 30 million of housing and then 45% of energy consumption, we see that it's really huge, and that the energy consumption, for example, represents 2 times more than industry. We have also spoke before of water consumption, and we can notice that the water consumption has been multiplied by 2 in 100 years, while it was 7 liters per day, per person and per day a century ago. And we have also spoken before of waste, but there is more construction waste than household waste. And in terms of emissions, it's also interesting to see that there is a problem of climate change, of course, but not only, and that's important to also focus on the indoor air quality. And there's a lot of different substances emitted with a cocktail effect, and this cocktail effect is really poorly known, as we spend 80% of our time in the interior. So it's also interesting to notice that. So if we look at the contribution of the construction, we can see that action on the building sector is important. Well, it represents 40% of the final energy consumption in Europe. And there is also a part of the building sector which is included in the industry, while the manufacturing of materials and so on. And we all know, I think, that cement industry is responsible of 5 to 8% of carbon dioxide emissions of the world. So construction is a kind of problem. So if we now focus on the concrete, the first component of concrete is cement, and the cement induces carbon dioxide emissions. So the concrete is the construction material the most used in the world. Around 6 billion of cubic meter of concrete are used per year, and this is increasing year after year. This is increasing year after year. The huge part of climate change induced by the construction sector is going to increase. So, but now we are going to see that not only climate change is concerned, but for example, the sand, as seen on this transparent, which means that sand is the most used resource after water, and we know that each year, except the COVID year, the global overshoot day, no, that was the one before, the global overshoot day appears earlier. So the global overshoot day, I don't know if you know, but is the day where we begin to consume more than the Earth can provide us. So the next one is about the consequences of climate change that we have seen before and that we all know, so such as extreme events, rising waters, melting ice, and the consequences linked through the biodiversity, which will conduct to disappearance of species. And what we can notice now is that we can see at our scale some effects of climate change. So the next one is because there is also other indicators, such as, for example, eutrophication, which is evaluating in the unit of phosphate. Eutrophication, here you have a beautiful illustration with green algae. Where do come from this impact? They come from the deterioration of aquatic ecosystem due to the nitrates, the phosphate, and organic matters, and that causes these kinds of beautiful things. Let's go to, sorry, the second one and the other one, which is acidification, I think. This. And then after the acidification, sorry. So another example of impact indicator, acidification in sulfur dioxide, in the unit of sulfur dioxide, which is due this time to sulfur dioxide, nitrogen oxide, and ammonia. And the specificity of that indicator is that it can be, it can go through atmosphere. Let's see the following one, exactly. The pollutants are emitted and then they can be transported for a very long distance. And the result, let's see the another transparent, can be this kind of result after acid rain, for example. So, and there is also some other kind of indicators. Here you have an example of smog at the top, the two photos of the top, waste, as you have seen in the previous presentation, and the last one on the back on the right is ozone depletion. And ozone depletion, it's interesting because it represents the only indicator on which we managed to make it decrease since we have signed the Protocol Montreal. So it's a kind of thing, a positive thing, which is not so common when we speak of environment. And so let's go to the next one. So there is a way to evaluate all that. No, just before, sorry. To evaluate all that, it's the LCA methodology, which can help us to reduce all our kinds of emissions. Next. Next transparent. This is here a kind of history of this methodology, which has been created at the beginning for manufactured products, and its adaptation to the construction sector is always under construction. So what we can see here is the first LCA tool, for example, came in 1988. LCA has two basic principles. The first one shown here is the fact that you have to consider the whole life cycle. So why is it important? Here is represented the climate change impact of a thermal vehicle versus an electric one. If you consider only the 3 steps of our life cycle, you could conclude that electric car is more impacting. But as we know, the use phase reverse these results. That's an example of the reason why it's important to consider the whole life cycle. So let's go to the next one. The other, the second basic principle of LCA approach is the fact that it's multi-criteria and that we are not going to focus on only, for example, climate change, but on a lot of indicators. So now, here it's an example of a LCA made on a building which consumes 88 kilowatt per square meter per year. And we can see that only one of the indicator is linked to water environment, the one with water pollution. This indicator is also the only one on which the end of life phase has the most important impact. So it's important to take into account different indicators related to various environments, such as water, air, soil, in order to avoid replacing an environmental problem by another. And LCA is a way to do all that. So next one is a kind of resume of what is LCA method and what we have to keep in mind. That it takes a whole life cycle through a quantitative way, and it gives results following different impact indicators. It's important to notice that the LCA method permits to evaluate alternatives, and it has not to be used to give a kind of notation of a project. It also has to be used in a comparative way. And well, in fact, we use it in order to find the best alternative. Next one. So here is the way LCA is divided by the normative. So the first step is the definition, the goal definition and scope. After the inventory analysis, the impact assessment and the interpretation. In fact, it's like in every kind of problems, you begin by your defining your hypothesis, and then you are going to check your data. You go through the calculation method and you interpret all the results. Next one. We are just going to watch through 2 case studies in the construction sector, how it can be used. The first one is linear infrastructure trackage, and the second one is the case of 3D concrete printing methodology. So first, for the linear infrastructure trackage, here you have the functional unit that has been used in the thing we made. So it's allow TGV type rolling stock to circulate at 300 km per hour up to 17 tons at the axle for an observation period of 100 years. So we have had to the second one, sorry, the following transparent. Okay, perfect. You have to click a certain, yes, another time, another time, another time again, and that's the end. So thanks. No, sorry. So what you the infrastructure has been the rail infrastructure has been divided into different parts, such as track, rail, sleepers, platform, with different types of layer earthworks, signaling with cables, the supply, and different types of works, such as bridge, tunnels, and so on. That's how has been built the model. And then the results in the following one. So the first result here is presented the result for the complete model. And what we can see here is that the most important part is the blue part, and the blue part corresponds on all the majority of impact that has been calculated. The blue part is the track. So the track has the majority of impact. So we want to understand why, and so we go through that. So let's go to the next one. So we are going to try to understand where does the impact comes from. And so here you have the repartition on the whole life cycle of the infrastructure. And what you can see is that it's the purple part which corresponds to the operation. And that's normal because for an observation duration of 100, there's a lot of materials, construction material, which are going to be changed. So now we are going to want to go through this phase. You can click once. Yes, and here you see that the majority of impacts come from what is blue. And what is blue is the fabrication of the new materials. So let's go to the next one. And then when we go through the fabrication of the new materials, we see that, in fact, it comes in majority of the fabrication of the rail, and then the fabrication of the sleepers. So in terms of eco-conception, we should work on this part if we want to have a better evaluation of the infrastructure, the linear infrastructure. So I wanted to show you another case study, which has been done last year at the laboratory in the thesis made by Katrina Kuznemenko on the 3D concrete printing technology. I'm going to go fast, I think. So this seems to be a new way of fabricating, of the fabrication of concrete. So we wanted to understand if it was a good idea from an environmental point of view or no. And so we made a modelization of LCA modelization of the robots. Let's go through the other one. So we have used a software as usual, which is called OpenLCA, and the database the most used in our community, and the boundaries of the system are cradle to gate, including the extraction of raw materials, the fabrication, transportation, and construction site. Let's go to the next one. Here you can see the whole life cycle model, which can be divided into the material part in cubic meter and the robotic cell, which has been calculated in how. The printing process is then described by each part of, and the functional unit can be there then evaluated. So let's go through our functional unit, which in our case was a printed filament with a volume of 1 square meter. Environmental impact is then calculated as explained here, with the sum of the material footprint, the robotic cell footprint, and the electricity, which has been evaluated by measures on site. So let's go to the next one. So the LCA model, which has been made by this thesis, takes into account each part of the printing cell. And as I said just before, measures have been done in order to take the real consumption of each part of this printing cell. And so this methodology can be adapted in various cases of robotic printing. And then here is an example of the results obtained for a printing section of 1 square centimeter with a printing speed of 200 millimeter per second. But this is just, this has not well, we have to change things in the model because we have to, the consumption was not exact, but it was just in order to show you the kind of results that we can have, and that the part of robotic cell and the part of construction varies following all the indicators, so it's not always the same part which has the most impact. So, as a conclusion, I hope you are convinced that it's important to go through the environmental balance in order not to choose a better solution, and that it can be applied on every kind of project, but sometimes with lots of difficulties in terms of data collection and databases. Thanks.
Thank you. Thank you, Adelaide. I think that your presentation is absolutely interesting because it's in line with the introduction by Hervé. And we have in the round table another one presentation done by someone from NG about the impact, what is the impact of the windmill and how the conception of the windmill on the low carbon. So it will be great to have some conclusion after the roundtable about this issue, about the question of not only of the question of materials, but the question of product and how to transform the material to product. And maybe it's one of the issue of the low carbon approach is to have more engineering in the transformation of the materials to the product for the construction industry. I'm suggesting to have a break of some times before to go to the roundtable. Because Gerson is supposed to make, you are going to do that, to explain how we're going to proceed for the lunchtime.
Yes, thank you very much, Christophe. I have to do some housekeeping. So due to sanitary measures, we need to have a seated catering. So when we will go for the lunch after the last presentation this morning, you will have to go downstairs. You will find the tables in the 3 side walls, and there will be 2 services for lunch. So please wait for the second service if the first one is full. And meanwhile, of course, you can visit the different booths and visit our supporters during the time you are waiting for the second service for the lunch. So thank you very much.
For the 2 services, take into account how we are reorganize the session of this afternoon with a shift of 15 minutes in order to have not to everybody at the same time. So take into account what is your selection of your session of this afternoon because there is 15 minutes of gap. So, okay, that is managed in this way.
Yeah, that was my second concern for the breaks. So for the lunch, 2 services. So if you go downstairs, if you have to wait, you can visit the exposition and the booths. And for the breaks, as Christophe said, we have shifted all the breaks that you will not be together at the same time for the breaks, so you have to select your time for the different sessions. Thank you very much for these housekeeping measures, and we are really sorry about that, but that was the only way to organize this conference during COVID-19 pandemic.
Thank you. So now I'm going to call Blaise here on the floor. Blaise, because I recognize nobody with the mask. So Blaise, you are welcome. Anne. So it's the first time I meet Anne. So and that's so okay. And then you will have online Chantal. Chantal, are you here?
Yes, I am.
Yes.
Hello, everyone.
Yes, Chantal. And Ville? Are you online, Ville?
Yes, I am here. Can you hear me?
Okay. And what I suggest is maybe to sit down, please. Just to introduce briefly how we're going to proceed. Blaise is here from Artelia to introduce, and for Syntec Engineering, to introduce the position paper of Syntec Engineering about the low carbon strategy and digital twin. Then we will have Chantal Alario from NG speaking about the European project Gaia X and the Green Deal and some use cases in Gaia X, and I already mentioned the typical case about the windmill approach. And then we will have Anne introducing the research done for FNTP. Anne is from Vinci, and she was committed by FNTP to prepare a research on the impact of digital process on the different process of design, construction, and maintenance. And then we will have Ville, who is in charge of a very huge project in Finland about the low carbon approach on this very large project in Finland. So we are going to mix presentation by Blaise and Anne on site, and from Chantal and Ville online. We have quite and we are going to take. We are in time, so it's good. So we have still 10 minutes at the end for the discussion. So okay, Blaise, you have the floor. Where is your presentation?
My presentation?
So you are no, I do not see, because
okay, I gave you.
So I'm going to load.
No, I have that.
Okay.
So we worked with quite 30 persons in Syntec Engineering to resume our point of view of what is a digital twin and what for a digital twin in our industry. Our goal is to demonstrate that a digital twin, as Mrs. said, it's a leverage to better understand our buildings, infrastructures are working, and how we can improve our impact on climate change. It's okay for you? Okay. You can pass all the slide, the first slide, not all, just the first one. So digital, it's a real job. hopeless. Okay, so what we want to say today is what is a digital twin? Maybe, good try. Let me try. Chips. Yeah. This one is the good one. Okay. What is a digital twin? A descriptive model, a relation or functional model, and analytic or simulatory model. It's a gathering of different models, and this one is a way to understand how we can work on static model, static information, and dynamic one at all the stages of a project. So we want to make a link, sorry for the English listeners, we want to make a link between reality and virtuality or digitality, okay? We want to digitize all information while we need to understand how a building is working, or how a bridge is working when there are wind, when all people go through the bridge, for example. So we need to link IoTs, equipments, and so on to a digital world. But what we want to do also is to have, in French we say frugal, but I don't know if in English you would say the same word. We need to limitate the information we have to gather from the sound. Because if we want to do that job correctly with the right information and the right data, we have to periodically, once a year, twice a year, maybe, have to make the right control of the sensors. Maybe a sensor don't really get out the right information, and you have to do that job. It's another reason why make a lot of sensors in a building or in an infrastructure is not the right solution. So what we need to do is to go through static to dynamic world to understand how all this buildings, infrastructure can be gathered together and understand how all this world can be improved. We are talking about system engineering. It's system engineering. It's another way to do our job of engineers. And all this information is in two ways. One is the impact on our industry, buildings, infrastructures, and cities. And the other one is in the maturity or complexity of the digital twins. So we have to work on these two directions. The contributions of a digital twin is on three important ways. during all the phases of a project of a building or infrastructure, we can imagine that a digital twin impact also resources, flows, and processes. Resources, for example, in design, maybe if you have generative design, for example, that impacts your conception, you can use another way to design your project. If you think about resources during the construction, you can, for example, if you see this picture with that man who is using the augmented reality, you can see how you can produce with less materials your building, for example. And during operation is another way to lower resources, because you can monitor all the information about the way your infrastructure is working. So resources is one of the most important way you can use digital twin. Another one is flows. When we use this kind of digital, we are arguing about the way a digital twin is a way to demonstrate how a building or infrastructure is used by human, and the flows, the way the way people use a building is a way we don't really have information today. And with the digital twin, we can be able to gather that kind of data. It's very, very important to understand how we can improve our design. And processes, of course, when we see during operation a building or an industry, we can, of course, play with all data that can improve the process. So, at the end, what we can conclude is a digital twin is a way to improve monitoring of our assets, better understand the physics that is involved in our business and performance of our assets, and improve also new construction methods. And for us, it's very important. It's also a virtuous process.
Thank you. Blaise, just to mention something that you have realized a video will be online to summarize all of you are mentioning about the digital twin and the position paper of Syntec Engineering about that. So it will be available on site during the day, and I recommend to have a look about that. Thank you very much, Blaise. Now, Chantal, you have the floor.
Yes, can you see
so
my
at the moment
screen?
you are not on the screen, but it's arriving.
As NG is actually co-leading the Gaia X Green Deal work group. So we're co-leading this work group with the French Ministry of Ecology and Sustainable Development. So I'm going to talk to you about the Green Deal in Gaia X and an example of a use case that we started working on. So I see that my screen is arrived.
Sorry, your presentation is on the screen.
Okay, it arrived in Lyon, so that's great. So the Gaia X, I won't spend too much time on Gaia X. I just wanted to give you this general picture. There is a lot of working groups on all those items, and it's really very rich. Space, agriculture, mobility in smart cities, smart industry, energy. It's really various items. As I mentioned before, we've been working with the French Ministry of the Ecology on the Green Deal group. So what is actually the Green Deal group itself? It's actually aligned on the axis of the European Green Deal. And all those axes, as you can see, are really cross the themes that are in the different Gaia X work groups. So, for example, there is the agriculture, also smart industry through decarbonization industry, there is circular economy, transport and mobility, and so on. So the work group on the Green Deal in Gaia X actually worked with different stakeholders through working sessions and to identify specific use cases for each of those items. As you can see, there are already some use cases, as I mentioned in the here. For some of the others, they were not at this time prioritized because of the people who were within the sessions, working sessions. It was not prioritized. So what were the objectives of the work group Green Deal in Gaia X? Is really to be an enabler to rethink policies on the axis defined by the European Green Deal. It also fits totally within the national hub's vision of developing a trusted European cloud market, while focused on meeting the needs of enterprises and public administrations. It really follows the approach focused on users' needs. The essential point is to have use cases for final users and users of data. One of the objectives is to federate all the players in the ecosystems or cross-cutting areas in order to carry out use cases and actions. As you know and you're well aware, Green Deal axes are very common to all industries, and when we talk about circular economy, it crosses all the industries, and it's essential to work really across those topics. And so that's what we try to do as a transverse workshop group and develop use case and actions to federate all the actors on all the items I mentioned before: clean energy supply, economy, industry, production and consumption, large-scale infrastructure, transport, food and agriculture, construction, and so on. And it's really to really aim towards a sustainable use of resources and also improve human health. So while this group has been working on all those topics within NG and working with across in relation with the smart industry and circular economy, we've been initiated a use case, which is the wind blade recycling. You all know that as renewable energy, wind farms are everywhere, and there is the power installed is increasing very rapidly. For example, in between 2001 to 2019, the installed power was multiplied by 20, and it's not going to stop, and especially with the increase of marine wind turbine. So it's going to continue increasing so much. At the same time, the lifetime for those wind turbines is 20 to 30 years, and that leads us to the fact that we're already starting recycling or dismantling wind turbines throughout the world. As it turns out, 85% of wind turbines are currently recyclable, and through the rotor, the foundation, the tour, the nacelle, all those parts are fairly easy to recycle. However, valorization of wind blades is really still scarce. I'm sure you've seen this image that was very surprising and very shocking to me, to see those wind blades laying on the ground waiting to see what was going to happen to them. So we evaluate up to 40,000 wind blades to be dismantled by 2023, which means at this point, if nothing is done in terms of valorization, is 40 to 60 kilotons of waste. So the idea of the use case is really to see how we can use a process that has been used before on other things to recycle. The main question at the beginning was really why wind blades recycling is so difficult and is so scarce. It turns out it's a very complex and heterogeneous composite material. If we look at the high level of the composition, it contains some adhesive, some wood, some resin and glass fibers. And as you can see in the center of this slide, the cross-section view of a wind blade. So it's really heterogeneous in the cross-section and also heterogeneous along the blade. And wind renders the sorting and guiding fairly complex, even though it's possible, but it remains something complex. And so what's proposed is really to valorize wind blades through a complex process, which is the gasification complex. And I'm going to talk just a little bit on this process. What it is, it's a thermochemical transformation of feedstocks, what we call feedstocks, which is our waste, by the action of heat and gaseous reactant. And what it produces, it's actually a synthetic gas. This gas integrates some synthetic methane, and obviously methane is something that we know well at ENGIE, and that's something that can be put into the gas networks and provide energy. So the project itself is it's not a new project. I mean, power classification itself is not a new project. It has been work has been done to optimize all the stages of the process, from the waste gathering through the syngas cleaning, all the way to maintain the synthetic natural gas and to use it. So we demonstrated that in the past. The project has been is a really group effort, as there are some 11 partners, and so at this point it's really each part is optimum. And the process chain is optimized. And what is going to be done is that to use this process to recycle wind blades. So in the conclusion, I would say that in order to do that and to collect all the data required so that we can optimize this process, the interoperability is essential in between the people, the constructors, as well as the users and the groups in charge of recycling. And it's the only way that we can optimize and improve the life cycle in a sustainable way. Thank you very much.
Thank you very much, Chantal. That's for me a very interesting presentation, in line with what it was introduced by Javier this morning, and coming from the engineer sector is something great, because it means that we need to change our feeling and your mind about how to design. So we have the digital approach introduced by Blaise, but it's not digital only. It's digital to change the way to design and to produce. That is really the transformation to be to engage right now. Thank you very much, and I hope there is some question for the end of the session. Ville, you have the floor. You are on the screen. And maybe we are not already the voice. Ville?
Okay, do you hear me now?
Yeah, yes, perfect. So maybe...
Do you see the presentation?
To introduce yourself right now, and then we can have your presentation. Thank you, Ville.
Okay, yes, my name is Ville Alajaki, and I work for the city of Helsinki, and I'm currently responsible for the Crown Bridges project. Have been for the last decade, roughly. And the view is from the project management point of view. So I presume my presentation is
yes, please.
Arriving shortly.
On l'a là? So it's coming. We have just a problem with the relationship between the table and the screen. Everything is okay from Finland to here. No, it's okay. Let's go, Ville.
Okay.
Thank
you. Yeah. Well, Crown Bridges started from this bridge design competition, and you see the result here. It's going to be the longest bridge in Finland. Now I can say when it has been finished. But the actual project is about a tramway connection to Laajasalo. And if you've been to Helsinki, you know the city center is in this picture on the western part of the picture, and what the project is about, it's about constructing a new tram, or we call it light railway line, to an island right next to city center. On Laajasalo, on the right, there's a new residential area being constructed, and the aim is to make a public transport route to the city center from the Laajasalo area. In city center, we are also constructing or some land for additional housing projects on the Hakaniemi area. The aim is to, as you see, to shorten the route from the island. It's going to be roughly half of the travel time compared to the case where you would have to take the current routes from and circle from the north to the center. The Helsinki strategy is about steady growth along rail lines, current and future rail lines, and here you see the population growth areas, and you see the connection to railway or light railway tracks, which are, it's a kind of a chicken and egg symptom that you begin to construct rail lines, and it makes the housing development feasible and economical, so the processes are simultaneous. What it does to our rail lines, here is a combination of the current rail lines in the center on the bottom part. Then there are also the railway lines and the subway line in Helsinki combined. But the yellow lines plus and this blue line, which is Crown Bridges, they tell the story of enlarging or building more tram lines to the Helsinki area. In the north there is Vantaa, and in the west there is Espoo, and the connections, the light rail connections are combining these three cities in the end to a combined network. And in Helsinki area, if you think about the amount of tracks, it's going to be roughly 3 times the amount of kilometers compared to the current situation where we are. We have been building tram lines for the 20th century, but it's sort of slow in the city local tram line, and now these new tram lines are designed as fast light railway lines, which are aimed to be able to transport residents to the city center and of course as a network around the area. Just a short combination from the project management part. We've divided the project into 2 different halves. We have an all-in bridge project on the left, where the construction have started last autumn. Then we have an IPD kind of alliance project on the right side, where we are one partner in an IPD project, where we are working together with in total 7 different companies who are responsible about the rail lines in a combined, let's say, startup company. If you look at the project hierarchy, you see that we are combining 2 totally different project types. The all-in contract is a traditional contract where the client purchases the design and then bids for are made, and the construction company is responsible for the construction phase solely with client's design work. And the alliance is then an integrated project type where we are responsible for the design and construction phase with our companies, and also sharing risks with the private companies. The scale of roughly starts from 2002, when the Laislo area began to formulate, and the first decade of the 21st century went by designing the master plan phase. Then the second decade we started to formulate the tramway line to Laislo area, and now in 21 we have started the construction works, and the phase 1 is aimed to be able to start the commercial service in the beginning of 27. The second part shall come after that, and you could estimate that the third decade of the 21st century goes on with the construction works. The idea behind this picture is to give idea about the time scale of the project. I'll come back to that later. So in short, we are in the basic project. There's 3 bridges and roughly 10 kilometers of tramway. But I kept this short that I can continue to the topic of the day. I'll discuss shortly about the BIM-based process in our project, and then how to combine BIM and sustainability, and where we are at the moment. So the BIM-based project is of course the first issue of a long-lasting project. in here we know about the theories about one model and softwares and so on, but it is a traditional way of describing a BIM-based process from the initial data to the maintenance models. The issues here are basically the interaction between different software and different models. The idea of one model is I think some sort of utopia. In practice, you will always have different models for different kinds of purposes, and we have to learn to make the process so that the data is flowing throughout the process from initial data through design phase and construction phase and through the production, let's say, subcontractors and so on, until we receive the information to the maintenance model. And in Helsinki case, on the bottom right, you see the end product. We have been gathering our 3D city model for the roughly last decade also. So we are now in the process of combining BIM models with the GML models, city models. But as you can imagine, the open BIM solution and the combination of small software is the key to be able to manage this. Since the project duration is roughly 15 to 20 years, you really need to start to think about larger scale issues than only the single 3D model of some structure. It's easy to look at the software involved in 3D modeling, and then on the people cases, they are normal issues raised on these projects where you have to learn to use new tools. But at the bottom there are some new areas where I think we haven't started to approach so much. We have, and Christoph was mentioning metadata this today earlier, and the approach to metadata is similar to what I have taken here as project management approach, where you have the decision management and task management and so on, where you need to be thinking about data other than the product itself, because the amount of data in a long-lasting project is exponential compared to the amount of data that is only relevant to the final product. The process data is much more important in this case where the design work is done in separate parts and it's kind of an iterating process. So this is another view of the same process. And then a third view of the same process comes from project management view and the separate companies, separate stakeholders and actors in the project. Yes, here is a simplified diagram of our project and data storage. It gives an idea about the data and information that you have to be able to combine from different projects. Which part of the data is supposed to be open for each party in the project. What is the contract type in each project? How deep can we see in those projects? In an IPD kind of project, it's based on open data also and open costs ideas. So we see quite deep through in that project. Then on the other hand, in an all-in contract, you only basically see what the contractor shows you. You only see what you have been able to define in the contract. But in any case, you have to be able to combine the data from different projects to manage the whole project. And you have to have a situation awareness. You have to know where you are. Well, that was some sort of background to give an idea why BIM is a process tool and why it's not a 3D tool. Then, if you start to think about sustainability issues, 10 years ago when we started this bridge project, carbon issues were not in the front of the table. So the process has been evolved in this last decade, but to be able to answer about the sustainability issues, you can start by the easy answer. We are building a tram line. The easy answer how we are responding to sustainability issues is that we are building an efficient lowest emission means of public transport, which in itself is a low carbon solution, a sustainable solution in many ways, not just for carbon, but in the transport system, but you can start to widen the horizon. But on the other hand, the construction process is also a source of carbon and sustainability issue. If you look at the construction sector as a whole, you realize that also the construction process has to change. We adopted first of all the SQL certification system a few years ago during the process, not from the beginning, but during this last decade. We started to sustainability issue and understood that it has to be from the process point of view. So the managing system now implemented in the alliance part where the main volume is constructed is taken into use, and of course there are these individual requirements where we have started to use low emission machinery and low emission fuels. We have studied and taken into use methods for decreasing waste and so on. There are individual small things to do, but they won't solve, I think, the carbon issue in itself, because you need to understand behind you need to understand the bigger picture of these individual things. But you can learn from this. You can start by investigating these acronyms in those areas. The SQL is some sort of managing method, but then you have the LCAs and CBAs and so on. EPD is an example of environmental data involved in one product. You can start to realize that it's not about this individual means, but it's about information harmonization. These are all harmonized ways of assessing the sustainability theme. And then if you start to turn the process view of the whole thing, you take the life cycle process and begin to think about what we are doing in each phase. For example, in the construction phase, the materials is the easy answer, I think, but it's sort of impossible answer also. We have concrete and we have steel competing about on each other, and the carbon issue is I think doomed if we leave it to be only between as a war of materials. But we actually need to start to think about the production methods for the materials, and we need to start to think about machinery and construction methods and how they are consuming carbon. Then the maintenance part, it's kind of has been like this for ages. We've used standard solutions and maintenance quality has been the issue where the carbon and Europe come from. Someone is I think has the mic on, so well, anyways, to come to the big part, the operation part, if you think about the information flow in these phases, you start to take into account the digital twin term, and in the operation part, you have to think about well, we call it big data, where you can start to combine the data from monitoring systems, GPS systems, cars or trams using the roads. There's lots of different data that you can combine and start to analyze the total amount of different emissions and resources used in the for example, on this tram line. You have to start to think about the fuel economy and fuel versus electricity. Think about where the electricity comes from. Is it produced from a coal factory or windmill factory? It's all data combined in the total project data. And of course, demolition phase, you need to take into account recycling possibilities and flexible structures, and to think about the possibilities of reducing emissions also in this phase. But the view here is about the process view and the data that has to flow through throughout the process. So in conclusion, it starts to seem that we are talking about harmonizing the data also other than 3D data. It's not just about concrete or geometry. It's about sustainability data, it's about carbon emissions. If you want to reduce carbon emissions, you have to be able to measure the emissions first of all. You can't improve what you can't measure. So the implementation of data management into the process and
Et tous les services urbains, eau, assainissement, collecte des déchets, mais aussi les politiques sociales, c'est la particularité de notre collectivité, même si ça vous concerne moins, et les collèges. Alors je disais, depuis 2013, nous avons un système de mise à disposition des données. Nous avons 536 jeux de données sur la plateforme data.grandlyon.com, dont 96 sur les transports et la mobilité, et encore 122 dans le champ de l'urbanisme, de l'occupation du sol. Mais la mise à disposition des données n'est pas une fin en soi, ni même une obligation réglementaire. C'est pour nous l'intérêt d'assurer une réutilisation large et pertinente de ces données, et partagée, bien sûr, puisqu'un certain nombre d'acteurs, publics et privés, et d'ailleurs votre Assemblée montre bien l'intérêt d'une pluralité d'acteurs sur ces sujets-là, donc il s'agit bien qu'un certain nombre d'acteurs puissent les utiliser. Nous avons un laboratoire d'innovation urbaine qui s'appelle le TUBA, qui contribue à l'animation de notre écosystème des acteurs du numérique sur le territoire de la métropole, pour valoriser cette ressource constituée à la fois des données, mais aussi de la richesse du croisement des thématiques et des domaines de compétences. Alors, pour nos propres besoins, nous utilisons ces données pour piloter notre activité, planifier, exploiter nos services, construire nos politiques publiques et aider à la décision. Mais nous avons aussi besoin de données produites par d'autres opérateurs, des acteurs économiques, académiques ou institutionnels du territoire. Et chacun de ces acteurs a aussi besoin des données produites par la métropole sur son champ de compétences. Et l'idée, c'est bien de les partager. Donc, nous nous sommes positionnés comme tiers de confiance entre le producteur de la donnée et le réutilisateur en construisant un ensemble de conventions et de licences de réutilisation. La majorité de ces données sont en open data pure, mais certaines sont soumises à une licence pour la réutilisation des données d'intérêt général. Et donc, nous avons un système initié par la métropole, mais qui est aussi répliqué au niveau national et international, ce système de licence pour identifier les réutilisateurs et s'assurer que l'usage de la donnée mise à disposition reste bien conforme aux objectifs d'intérêt général des politiques publiques. Alors, pour ce qui concerne la surveillance des ouvrages, que nous avons nombreux dans la métropole, que ce soit des ouvrages sur les fleuves ou des ouvrages en tunnel, nous avons depuis longtemps un système d'information géographique pour inventorier l'ensemble des patrimoines que nous gérons, des voiries, des ouvrages, des usines, des réseaux. Qu'au fil des ans, ce système d'information géographique décliné en divers logiciels métiers s'est modernisé, s'est enrichi. Et du coup, ce patrimoine de données est en lui-même d'une grande valeur. En plus de nous aider à gérer les patrimoines physiques, évidemment, ces données numériques elles-mêmes sont d'une ouvrage sur leur état de santé, sur leur fonctionnement et sur l'historique des interventions déjà réalisées. Pour gérer toutes ces données, évidemment, il y a une question de moyens, d'outils et de moyens humains, de ressources humaines pour les administrer, les exploiter, garantir la fiabilité de ces données et des procédures pour assurer la bonne traçabilité des modèles de données, des processus de gestion du cycle de vie des informations sur les ouvrages. Et donc, pour nous, l'avenir passera par l'acquisition de systèmes techniques utilisables en mobilité sur le terrain par tous les agents qui en ont besoin, par les équipes opérationnelles, pour déplacer la consultation et la mise à jour des données numériques au plus près du terrain pour être toujours dans un souci de plus grande efficacité et de fiabilité pour la gestion de nos patrimoines. Alors, vous voyez que la métropole est bien outillée, qu'elle est proactive, mais elle reste ouverte à toute proposition pour expérimenter encore d'autres dispositifs, que ce soit sur le plan technique ou sur le plan de la gouvernance, et pour gérer de façon toujours améliorée nos ouvrages, nos patrimoines, nos infrastructures, notamment dans une vision de transition écologique, de mobilité durable, de villes respirables et apaisées, et de pérennité dans nos infrastructures de mobilité, bien sûr. Voilà, j'en dirai pas plus. Je vous souhaite un bon séjour à Lyon, surtout pour ceux qui sont là en physique. Et je me permets une petite conclusion en anglais, juste la conclusion, désolée de ne pas m'être exprimée en anglais. Mais for you in the room, enjoy in Lyon. Merci.
Merci bien d'avoir participé, d'avoir pris le temps de participer. Juste, je posais la question à Paul, mais moi, je viens de commencer la retraite, mais la Courly était quand même la première communauté urbaine, il y a plus de 30 ans, à avoir mis en place un SIG qui était le premier SIG en France, orienté objet pour les spécialistes. Et c'était quelque chose de très impressionnant à l'époque. Et on a participé, nous, dans Mind, à des discussions avec le CNIJ sur l'interopérabilité entre les systèmes en place, notamment, donc il y avait les gens de la communauté urbaine, et puis ce qu'on produit dans la construction autour du BIM, etc. Donc l'offre est entendue. Nous avons bien entendu ça et c'est quelque chose qui nous intéresse au plus haut point. Il y aura d'ailleurs une présentation c'est pas aujourd'hui ou demain, des travaux qui ont été faits à la communauté urbaine de Lille, par ailleurs. Et donc voilà. Mais Lyon, ça fait partie des 3 ou 4 villes en France. Il y a Strasbourg, il y a Lyon, il y a Lille vraisemblablement, qui ont été en pointe sur la numérisation des processus digitaux de tout ce qui est l'environnement du territoire et de la ville. Donc merci bien d'avoir participé, on en est très très fiers et très très contents. Merci bien. So we are continuing. Anne is for you for the floor, and your presentation is there. Yes. So we're going to load it. To load it. So okay. Franck, il n'est pas là parce que je sais pas quand. Non, je vais essayer de introduire. Je vais essayer de démarrer le truc puis présenter. Il y a un password là. Merci. Vas-y, à toi.
Oui, mais c'est pas projeté. En fait. Ah, okay.
Yes, it's okay.
We are facing the most important challenge of this century, and this is climate change. It has been said before, and we are running out of time. So the BIM for infrastructure must have some substantial consequences on the environmental impact of the construction sector. But the problem is, we can say that, but we don't know in which direction we will go, because there are some potential optimization on the construction processes, the maintenance, but there are also some impacts, environmental impacts from the digital layers and digital systems we add to our world. So the question was asked to FNTP, is digitalization of the road sector and the construction sector is good news for climate change and for the environment, or isn't it? And so at Vinci and Eurovia, we decided to accept the challenge of robustly, scientifically quantify that on a function of the beam that we really know very well because we use it for decades now, and this is pavement management systems and how we can optimize design, construction, and maintenance based on some data from the field. So I present the study today. My name is Anne de Bortoli. I'm a research scientist at Polytechnique Montreal, at École des Ponts et Chaussées, and at Vinci. I'm the life cycle assessment lead at Eurovia. I coordinated the study, but we were several contributors, so namely Yvan Droiden and Mustafa Mazdan from Eurovia, Alban Agnier and Sylvain Guillotot that I see there from Vinci Concession and especially Autoroute du Sud de la France, and Yacine Baouch from Université Technologique de Compiègne. So we have several ways to design and maintain roads in France and around the world. The most standard way to design a road is to design it to be able, from the start, to carry all the traffic we project over its lifespan. We call that massive design, and then we do some maintenance just to preserve the surface condition of the road, namely waterproofness and skid resistance for safety. Then we can, based on some mechanical empirical equations, so basically physics, we can use some more advanced tools than the standard documentation from LCPC, etc., that date from the 19th. And so we can use Alizé, and at Eurovia we have a special tool to design and maintain our roads called Odin. And so with this advanced tools, we can, and based on mechanical empirical equations, we can do either massive design or progressive design. What is progressive design? So it is when you are not exactly sure about the traffic in the next decades, and you're not exactly sure about the climate conditions. And this is exactly the case today, because with climate change, we will have some we won't have the same patterns, climatic patterns as in the past. So it's very interesting, and it can also be a good way to invest less at T0 if you're not sure about future conditions. So very interesting today. And with this progressive design, what you can do is, for each maintenance operation, you can add some mechanical structure to your pavement. So you don't just maintain to have a good skid resistance or waterproofness, but you also add some mechanical carrying capacity. But to be able to really optimize maintenance, you need something else. You need to monitor your road. You need to know about its condition over time, and you need to know how it reacts to traffic and climate. So to do that, we gather some information on the road condition with most of the time equipped vehicles, but we can also use sensors, IoT, and we transfer this data in pavement management systems that are some tools where you can analyze your pavement condition and decide when is the best moment for you, depending on your KPIs, to maintain your road. And so, because PMS, pavement management system, is one function of the beam, and a function that we know very well and we are able to assess and quantify, we wanted to answer this question: are PMS a way to improve the carbon footprint of road construction and maintenance? So we conducted a case study we first look at a highway with 2 lanes in each direction. The traffic class is T1, meaning 500 heavy vehicles per day and per direction. The lifespan of the highway is 30 years, and we considered a 10-kilometer long section with a platform class PF2QS, meaning QS for superior quality, when we commission the pavement. The thing is, so the class of the platform is very important in terms of carrying capacity and in terms of how you need to maintain your road. And the thing is, the platform class evolve over time. It evolves because you can have some drainage problems, you can have some floods due to climate change, you can have even some improvement of the platform class, especially in urban condition, but because your pavement will be, due to the traffic, compacted. So what we wanted to compare in terms of carbon footprint based on the life cycle approach is the carbon footprint of reference 2 or scenario 2, doing a massive design with a surface condition maintenance, or reference 2, doing a progressive design with a mechanical maintenance but without monitoring the road. And the variant is a progressive design with a progressive maintenance plan that will evolve depending on how the platform class evolve in reality. And to monitor that, we have the PMS. So what we need to quantify is the carbon footprint from these different roads, construction, maintenance, and for scenario 3, we have to quantify the carbon footprint of the PMS. So the PMS, if we need to know how much the platform, what is the condition of the platform, we need to use, with Vinci Concession, it's mostly a big truck that is equipped to quantify the deflection of the platform. And it is going every year on each direction of the highway to model the carbon footprint of the PMS. So we have to take into consideration the data transfer, the data storage, backups, and exploitation. So how you analyze them. And there you have several sources of carbon footprint. You have, of course, the hardware. You need like physical servers, infrastructure, computers. But then you also have the energy consumption. About the digital layer, so we got the data from ISF, and we knew how many operations we need to conduct for a specific network of highways over a specific period of time. We quantified the number of files and the number of gigabytes we needed to have a PMS that work well, and how much time we need on computers to analyze the data and use them to optimize the maintenance plan. The quantification, the unitary impacts of the digital layer has been quantified based on the EcoInvent database. This is a reference database to conduct life cycle assessments, and the base carbon de l'ADEME. We consider IPCC last characterization factors for the different greenhouse gas emissions. So just a short focus, this is the impact, the carbon footprint of a pavement management system. And what is very interesting is first, you see that to optimize the maintenance of a highway, you will emit 1.3 kilograms of CO2 equivalent per kilometer and per year, and 1/3 of this impact is due to the electricity consumed to store your data. So the amount of data you have is important for the carbon footprint of your system and your BIM. Then 2/3 of the impact is due to the equipped vehicle, even if it only goes on the highway once a year. Then for the construction operators, construction and maintenance, we use the data, the results I developed in my PhD at École des Ponts et Chaussées. Also based on life cycle assessment, so we really consider the carbon footprint from the raw extraction, like crude oil for bitumen, aggregates in the quarries, to the construction of the pavement. Here are the different impacts we have. So for the different scenarios, and for scenario 3, we have different possibilities in terms of platform evolution over time. In scenario 1 and 2, we don't know the evolution. It evolved, but it will just create some larger portion of rehabilitation of the highway over time. But for the scenario 3, because we adapt the maintenance plan to the real condition, you can see that in blue you have a smaller impact of the maintenance for scenario 3, where the platform goes from PF2QS to PF3. That is a better platform. And here are the final results. So you see, we consider, so this case study is about considering that the platform will evolve after 10 years toward PF2, so decreased carrying capacity over a length of 10% of the highway, and it would evolve toward a better carrying capacity over 30% of the platform. The rest will stay stable. And so you have scenario 1 with the massive maintenance, scenario 2 with the massive design, scenario 2 about the progressive design and maintenance without knowing about the real conditions, so without any optimization, and scenario 3 about progressive design and progressive maintenance, optimized maintenance with the PMS. In red, you have the impact of the PMS. So it's totally negligible. What you can see is that between a very standard way to design and maintain your road and the best advanced way, you can save up to 24% of the greenhouse gas emissions. Between the progressive design without PMS and with PMS, you still have 4% of GHG emissions saved because you can optimize your road, and so you optimize the maintenance, you have a decrease rate, a decrease demand in rehabilitation over the lifespan, etc. We also made a national extrapolation. So this shows, depending on the kind of network, that we can save, thanks to progressive design and optimized maintenance with the PMS, the equivalent of 1,220 French people emissions over 1 year, each year, on the highway network. It's a bit less on the national network that is not under concessionaire management, and then there is a very huge potential on departmental roads. First, because it's a very long linear length, but also because maybe design and maintenance are less optimized than on higher traffic roads. To conclude, should we invest in the digitalization of the road industry for a desirable and sustainable future? When you consider the usage of BIM for the PMS function, the answer is clearly yes. The impact of the digital layer is really, really low. It's totally negligible when you compare it to construction and maintenance impacts. When you look at the impact of PMS themselves, most of the impact is due to the collection of data on the condition of the road, and we can optimize that with potentially sensors or electric vehicles. But, and Adelaide Ferrai told it before, we have to consider the multi-criteria environmental impact of these systems. From a carbon footprint point of view, it's very clear, but you have other impacts that are gaining some importance because it's a trade-off, and for instance, mineral resources are going to be depleted at some point if we don't deal with that from the start. So there is also the fact that we only consider the optimization of maintenance thanks to this function, this potential function of BIM, but we see other potential environmental gains from BIM. For instance, I show in my PhD that the most important impact of the road networks are due to vehicles. It's something like 95% of the carbon emissions. And so, yes, we need to optimize construction and maintenance, but to optimize the entire system. And to optimize the entire system, we need to monitor and optimize the surface condition of the road and the geometry of the road to decrease the energy consumption from the vehicles. For now, like, the trend is pretty positive. We can really expect some good improvement from an environmental point of view with the BIM in the road industry, but we have to be cautious about artificial intelligence, because we already know today that the calculation, deep learning calculation, are very energy consuming. So we have to make some quantification to be sure that we stay in a sobriety world. Limit and perspective number one about this study. So of course, we only look at one function of the BIM. They can be so many functions, so it's a multifunctional objects, and this is an unstable, still under development object. So I think we have to remember this, the principle of optimality that has been system optimum is different from the optimum of the entire system. And with the BIM, because we are talking about interactions, big system with subsystems, we really have to try to optimize it as a whole. And this is, of course, challenging, but we can make some very interesting studies with robust calculations. And we will need to optimize it recursively to reach the systemic optimum at each time of its development and usage. Limit and perspective number two, and this is the last one. Of course, the environmental impact of something is evolving and also depend on the market or the country or the region you consider. So today we know that the digitalization of the world accounts for around 4 24% of the greenhouse gas emissions worldwide. Half of that is due to the energy consumption. The rest is due to the hardware, the physical infrastructure and material that we use to make them work. But depending on where you use your system and where the energy, the electricity is consumed, of course you can have a difference of an order of magnitude of 100. For instance, in Quebec, you have an electricity that has a carbon intensity of 24 grams of CO2 equivalent per kilowatt per hour. In China, it will be 500 times that. So depending on where your servers are, where your data are stored and backup, you will have different impacts, and this impact will evolve because hopefully we expect that the electricity carbon intensity will decrease. So we have to measure all that, to simulate all that, and to decide where to go and how and what kind of function we can expect and implement in the BIM. Thank you for your attention.
Merci beaucoup. Thank you a lot, Anne, for your very brilliant presentation, very clear. Thank you very much. I understood everything, so it's good. Sorry, because we are already late, so I think that if there is no very crucial question, I suggest to close the session, except that there is someone who wants to say something on the floor, on virtual. No, so thank you very much. I think that it was a very interesting session, very new for the BIM environment to have this time to discuss about the not only digital approach, but what is the impact of the digital approach of the design and the construction. That is really the tools we want to develop. It's for that, it's not for digitalization by itself, but for the impact of the construction. Thank you very much, and see you during the next session of the day. Thank you very much.
Je fais toujours la logistique. Pour le déjeuner,